Hi guys, it's Mrs. Blake again, and today we're going to continue our discussion of stoichiometry by taking a look at the concept of limiting reactants. Limiting reactants is stoichiometry, but it's got a little bit of a twist. Now with limiting reactants, you are going to find some vocabulary words that you will probably want to know the definitions for, so you may want to pause this video and get something to write a few definitions down because you may need to use them later. So to introduce our concept of limiting reactants, we're going to go back and take a look at a ham sandwich. And as I go back to take a look at a ham sandwich, we are going to be using 2 pieces of bread, which is standard, 4 pieces of ham, which might be a little bit more than what you usually use, but 4 pieces of ham, and we're going to make one sandwich. And in an equation form, it looks like this: 2BR, 4HM, and 1 sandwich. And to introduce the concept of limiting reactants, the first thing I want to know is that this is the same stoichiometry that we've been doing when we take a look at a stoichiometry calculation. Nothing has changed calculation-wise. But concept, well, we're going to apply a concept. So we're going to take a look at this problem kind of to introduce ourselves. And as I take a look at this problem, it says, part A, if there are 24 moles of bread, how many moles of sandwiches can be made? And that looks pretty much like a standard stoichiometry problem. You have a number with units of one substance, and you have a question asking you to go to some units of another substance from that balanced equation. So I always start with my number, so I'm going to take this 24 moles of bread, and it's already in moles, which is great because that means I don't have to get it to moles. I can go straight to my balanced equation. So moles of bread is going to go on the bottom so it can cancel out. In my balanced equation, I can use my mole ratio, which of course is a ratio of moles, so it's moles to moles. But that mole ratio allows me to switch to any other part of that balanced equation. And so in this case, I'm going to switch to moles of sandwiches. So that's going to be Br2HM4. And these numbers come from the coefficients from the balanced equation. So I have 2 moles of bread to make 1 mole of sandwich. And that's going to cause my moles of bread to cancel out. And I'm going to multiply across the top, and I'm going to divide by the bottom. And I can come out with 12 moles of sandwiches. Now I realize that most of you probably could do this problem in your head without writing anything down. But remember that most stoichiometry is a lot more complicated than this, and usually we don't start with moles. So I have 12 moles of sandwich. But do I really? Can I really make 12 sandwiches? Well, let's continue on in the problem. Because in part B of the problem, we're talking about 16 moles of ham. And I still want to know how many sandwiches can be made. So I still have this starting number, but this time I'm going to start with ham. And it's still moles, so I'm going to set up my problem the same way. I'm going to put moles down here. So I can get rid of my ham. And this is still going to be a mole ratio, which of course is moles to moles. And the question continues on, how many moles of sandwiches can be made? So I'm going to go to the exact same point. Except for the coefficients for my balanced equation now are going to be a 4 in front of the ham, and still a 1 in front of my sandwiches. And again, multiplying the top, dividing the bottom. But this time, I can make 4 moles of sandwiches. So the question becomes, how many sandwiches can I really make? So if I take a look at part C, if I start with 24 moles of bread, which is what I started with in part A, and 16 moles of ham, how many sandwiches can I really make? And why? It says use no new calculations because we're going to use part A and part B. So part A says I can make 12 sandwiches. And sure enough, I have enough bread to make 12 sandwiches. Part B says I have enough ham to make 4 sandwiches. And the reality is I need both ingredients to make the sandwich. And if I have bread but no ham, it's pretty impossible to make a ham sandwich. So when I take a look at the answer to part C, it's not one ingredient that's going to determine the amount of product that can be produced. It's both. Ham is just ham, and bread is just bread. And if you don't have the other ingredient, then you can't make a ham sandwich. So while I have enough bread to make 12 sandwiches, I only have enough ham to make 4 sandwiches. And that means I'm going to make 4 sandwiches. And while I will have leftover bread, if I don't have ham, I can't make a ham sandwich. So here's where the concept comes in. Limiting reactant is going to be a term that you're going to see used. And limiting reactant is going to be the reactant that is going to run out in a chemical reaction. And in our example up above, I ran out of ham. And while I still had plenty of bread, I didn't have any ham. So when we talk about finding the limiting reactant is going to produce the smallest amount of product. So if I look at my answers, I can have 12 moles of sandwiches from my bread, but I can only have 4 moles of sandwiches from my ham. That's the smallest amount of product. The limiting reactant is going to stop the chemical reaction. And what do we mean by stopping the chemical reaction? Well, you cannot make any more ham sandwiches if you run out of ham, so the reaction stops. So if I had to identify and label the limiting reactant, now here's a key thing as far as reactants go. When we talk about limiting an excess reactant, remember in my chemical reaction, the ingredients are going to be my reactants. So if I am looking for a limiting or an excess reactant, it is going to be one of my 2 ingredients. And yes, there's chemical reactions that use 3, 4, and 5 ingredients, but we usually focus with 2. So when I take a look at those reactants, the limiting reactant in this equation is going to be the ham, which is the ingredient that produced the smallest amount of product, and it is the one that ran out in the chemical reaction. No more ham. So second term that we deal with then is the other ingredient or ingredients. It's excess. And what do we know about an excess reactant? An excess reactant is the one that's going to have material left after the reaction. I did not use up all of my bread. I still have a bunch of pieces of bread left because I ran out of ham. So the reactant that is going to produce the larger amount of product is going to be what we refer to as the excess reactant. And again, there's leftovers. There's things that's left. And again, from our example, when we take a look at our example, this is going to make it into our bread. We have plenty of bread left. So when we take a look at any chemical reaction, if I'm going to look at making table salt and make NaCl, in order to make NaCl, this is going to be my source of Na, and this is going to be my source of Cl. But when one of these ingredients runs out, There's no way possible for me to make NaCl. So in a chemical reaction, you need to look at all ingredients. And determine whether or not how much product that can actually be produced. Because when I take a look at a chemical reaction, NaCl is produced by both the Na and the Cl. So the concept of limiting reactant says that both ingredients are important in a chemical reaction. And so stoichiometry really has to become a stoichiometry problem for both. And the one that is going to produce the smallest amount of product, we call the limiting reactant. The one that produces a larger amount of the product is going to be an excess reactant, and the reaction actually chemically stops when you run out of one of your ingredients. In the next video, we'll take a look at these actual calculations and how to do these actual calculations. But today we're just going to be content with taking a look at the concept. So I'll see you guys in the next video. Thanks for watching.